two lines are graphed on the same coordinate plane. The lines only intersect at the point 3, 6. Which of these systems of linear equations could represent the two lines? So if the two lines are intersecting at the point 3, 6, that means that's the solution to the system of equations. So we need to see which of these systems have the solution of x equals 3 and y equals 6, which would mean that they are the lines on the coordinate plane. Now the first system is x equals 3 and y equals 6. That's a vertical line x equals 3 and a horizontal line y equals 6. And those are literally the values of our ordered pair. That's where those two lines are going to intersect. So system number 1 is definitely a system that could represent the two lines because it has that solution. They're intersecting at 3, 6. You have x equals 3 and y equals 6. We don't have to solve the system to know those are the values. The second system is not as easy because we have expressions for x and y. We have the lines x equals 6 plus y and y equals 3 plus x. So here we can try to solve this system. The best method would be substitution since we have variables already isolated solved for. So if we substitute in 6 plus y for x in the second equation, that would give us y equals 3 plus and then 6 plus y. So that would give us y equals 9 plus y. And if we subtract y from both sides, we actually get 0 equals 9. And 0 equals 9 is a false statement. So that means that this second system actually doesn't have any solution. There's no solution to the system. So it can't have a solution of 3, 6 if it has no solutions. So it can't be the system for choice 2. Choice 3 is the system of y equals 3x minus 3 and y equals x minus 1. So these lines are both written in slope-intercept form. They're both solved for y. And they don't have the same slope, that coefficient of x, so they're not going to be parallel. They will have a solution, but let's see and solve for if that solution is 3, 6. We can solve by using substitution by substituting in 3x minus 3 in for y in the other equation. That will give us 3x minus 3 equals x minus 1. If we solve for x, we'll subtract x from both sides. So 2x minus 3 equals negative 1. We'll add 3 to both sides, meaning 2x equals 2. And dividing both sides by 2, we get x equals 1. So this solution to the system will have a value of x equals 1. But right away, our point has a value of x equals 3. So although this third solution has a system, it's not going to be the ordered pair that we want. Right? This third system has a value of x equals 1, so it's automatically not going to be x equals 3. Let's move on to the fourth system. We have x equals 3 plus y and y equals 6 plus x. So again, let's use substitution to solve this system and see if we get the ordered pair of 3, 6. So we'll substitute in the expression of 3 plus y in for x in the second equation. So that will give us y equals 6 plus not x, but 3 plus y, which is y equals 9 plus y. And if we subtract y from both sides, we end up with 0 equals 9. This system is extremely similar to the second system. The variables cancel out trying to do substitution, and we get a false statement. So this is another system that is not going to intersect at 3, 6, but would be two parallel lines and could not represent the lines on the graph, right? It can't have a solution of 3, 6 if it has no solution at all. Finally, system 5 is y equals x plus 3 and y equals 2x. So again, we don't have parallel lines because both equations are written in slope-intercept form. We can see they have different slopes, but let's see if these two lines intersect and have the solution of specifically 3, 6. So we'll use substitution again. I'm actually going to substitute in 2x for y in the first equation. So that will give me 2x equals x plus 3. And to solve for x, we'll subtract x from both sides to get x equals 3. Well, so far so good because in our solution, x equals 3. So now let's substitute that into either equation in the system and see what y equals. Well, y equals 2x, and we just found out that x equals 3, so 2 times 3, so y equals 6. So that fifth system does have a solution of x equals 3 and y equals 6. It has the ordered pair 3, 6 as the solution, which is what we want. So the fifth system does and could represent the two lines. So our systems that we found work. Our system 1 and 5, they both have a solution of 3, 6. So that makes our answer choice D.